Good evening, and thanks for joining tonight's TI Technology webinar hosted by Texas Instruments, where tonight we're going to focus a little bit on the ACT and activities that will promote conceptual understanding. My name is Mike Houston, and I'm the moderator for this event. I teach algebra and calculus near Pittsburgh, where I use TI technology to make tough to teach, tough to learn concepts accessible to all my students. Tonight, I'm excited to be joined by our two panelists, Tom Reardon and Scott Knapp. Tom taught at Fitch High School in Austintown, Ohio for 35 years, and has also served as an adjunct professor at Youngstown State University for the last 34 years. As a T-Cube national instructor, Tom has worked on the development of the TI SmartView emulator software, the TI-Nspire CX, and TI-Nspire Navigator. Tom currently works for TI in product strategy and development. Tom, thanks so much for joining us.
Yep, great to be here.
And Scott is in his 20th year of teaching high school math. He currently teaches Algebra 2 and AP Calculus at Glenbrook High School in Northbrook, Illinois. Scott is a T-Cube regional instructor and has led numerous workshops on the TI-Nspire graphing calculator, as well as served on authoring teams for TI-Nspire and T84 professional development. Scott enjoys presenting sessions at local, regional, and national conferences on how to use technology to support student success in learning mathematics. Scott, thanks for joining us.
Thank you, Michael, and good evening to everybody on.
We're expecting a large crowd, so your audio is muted. Feel free to send any questions to Tom or Scott using the Q&A window on the right side of your screen. We'll also be using the chat window to send general messages. As a reminder, the session is being recorded, and we'll provide a link to the event certificate of attendance at the conclusion of the webinar. We hope you don't have any audio issues tonight, but in the event that you do, try selecting Communicate from the very top of the menu and choose Audio Broadcast. At this point, Scott is going to discuss our agenda.
Mike, have you
Scott,
shared with me? I am here, yeah.
Can you just talk through our agenda for tonight?
Oh, it's on there. Sorry. Yes, I was looking to be sure to. We just finished up welcome and introductions. Tom and I are both going to be sharing some activities and ways to use the different platforms, the two different TI platforms to leverage some success in the calculator. I'll be talking tonight more about the TI-Nspire CX and the topics matrices, functions, systems of linear equations, and properties of exponents. And Tom will be talking about activities related to the TI-84 plus, Pythagorean triples, absolute value, percents, and mean and median. For those that stay till the end of the webinar, we'll actually be hosting a little drawing for a free entry to our T-Cubed International Conference coming up next spring.
Thanks so much, Scott. And Tom is going to discuss our expected outcomes.
And what we're going to do tonight are view activities that help students learn ACT test concepts, learn ways to leverage both the Nspire and the 84 technology to solve problems on the ACT test. And you'll also get familiarized with some of the question types found on the math part of the ACT.
Thanks, Tom. Scott, you have control. Feel free to share your screen.
I will now. Yes, thank you very much, Michael. Okay,
Thanks, Scott.
So, I'm going to go ahead and start my part of the presentation tonight. So I'm going to be working with the TI-Nspire CX, as I said. And the first topic I want to talk about tonight involves matrices, which is something that we cover, but how much do we cover? But it's important that we do as far as the ACT goes, because there are some questions related to matrices on the ACT. So we actually put together an activity. I think the thing that my students struggle with the most involving matrices is multiplying matrices. Adding and subtracting and multiplying by a scalar are tasks they can pretty much do. But multiplying matrices is a little bit more challenging for them. Specifically, when can they multiply, when can't they, and what are they actually creating when they multiply matrices? So we put together an activity, and what you're seeing on the screen right now are we put 10 different matrices into a TNS file on the TI-Nspire calculator. And we're going to have students kind of explore products of some of those various matrices and see if they can come up with some ideas on how we can actually multiply matrices and when can we. So I'm going to come over to that TI-Nspire file right now. And as it says here on this screen, we've got 10 matrices entered A through J on the next screen. And this is what I took a screenshot of that you saw on the previous screen. So those are already pre-entered. And now we can access those to complete the activity. So I'm going to slide over here to page 1.3, and that's where I'm going to do all of my calculations. But here's what the activity looks like. Let me pull up that slide. So students are going to take the matrix in the first column and multiply it by the matrix in the second column, and look at the dimensions of the two matrices being multiplied as well as the dimensions of the product. I'm going to come back to the calculator screen, and we're going to look at the first row, and I'll probably do a couple of rows here in the table. So matrix A and matrix D. And I'm going to go ahead and type A because that's how I can access those matrices that were entered over here on page 1.2. And I'm going to press enter here, but before I do, I want you to notice that when I typed A, it's bold, and the reason is that's now referring to something that's been stored into A, and that is matrix A. So I'm going to press enter just so we can see that students would want to see and notice that that's a 2 by 2 matrix. And then the other matrix that I'm going to multiply that by is matrix D. Again, you'll notice that it's bold, and that's a matrix that's 2 by 3. And so the product of A times D, I'm going to go ahead and type in A times D, and those two matrices do multiply, and they end up giving me a 2 by 3 product. So if I come back to my slide here, we had a 2 by 2 and a 2 by 3, and that resulted in a 2 by 3. So I always tell my students that one example is not enough to notice a pattern. You probably have to look at a couple more. So let's do one more, C times A. And the nice thing about this is because there's so many different matrices in there, we have a lot of different combinations that we can use. Let me get my calculator screen here. So matrix C is a 3 by 2, so that's something that we haven't seen before. And matrix A is that 2 by 2 from before. And if I multiply those two matrices together, I end up with a 3 by 2. So again, coming back to my slide, we had a 3 by 2 and a 2 by 2, and that yielded us a 3 by 2. So if we just kind of look at the rest of the table, if students were to go through this, this idea takes a while for students to kind of see and notice, but one thing we hope that they notice is that the number of columns in that first matrix needs to be equal to the number of rows in that second matrix. So that's the key to understanding when matrices can be multiplied is if those two numbers are equal. So the students have a follow-up question to this, and that is just, once you've looked and noticed some patterns, can you make some conjectures? The first would be that it is possible to multiply two matrices if the number of columns in the first matrix is equal to the number of rows in the second matrix. And now coming back, another question here up at the top, make conjectures about when it is possible to multiply matrices and how to calculate the dimension of the product. If we come back to the table, we'd like students to kind of look at these two, or this column here. The first column here being the number of rows of the first matrix matches up to the number of rows in the product matrix, and that the number of columns in the second matrix matches up to the number of columns in the product matrix. So what we want students to get out of this activity is just a real quick look at a whole bunch of different products using the TI-Nspire to notice when it's possible to multiply two matrices, as well as how to determine the dimensions of the product matrix. And that's typically how I start off teaching multiplying matrices, but I think this activity does a great job of allowing students to kind of notice those patterns and come up with that idea a little bit on their own. And then, tonight's about, how do we use the calculator, how do we use either the TI-Nspire or the 84 to be more successful on the ACT. Of course, we teach the students how to multiply two matrices by hand, and I always have students kind of look at the dimensions of each matrix in the product and first of all create themselves a little bit of a template that they're trying to fill in. so that they kind of know where this is headed to. And we would like them to know, how to multiply two matrices. I usually have students stick with the first column and then go through each row and multiply corresponding members and then fill in that first column of the product matrix. And then I have my students kind of block out that first column in the second matrix because they're kind of finished with it at this point, and then go back through the rows of the first times the columns of the second. And we certainly want them to know this math, and that would be really helpful. But on a high-stakes test like the ACT, is there a way that maybe they can achieve this with the calculator with a little bit of help? So I'm going to show you how to enter these two matrices into the TI-Nspire and how to come up with that product. Because there's certainly a lot of places where students could make a mistake in multiplying these two matrices, as well as take quite a bit of time. So if we come back to my calculator screen, which is right here, the way to enter a matrix into the TI-Nspire calculator is we need to access this template key. And the template key is here just a little bit to the right of 9 and to the left of the catalog, and that's where you find a lot of the different templates that you use in your math classes. But in the second row, there are 4 different matrix templates, and we have the ability to choose either of those 4, one being a 2 by 2, this is a 1 by 2, a 2 by 1, and then this last one, it looks like it's a 3 by 3, but in reality, if we click it, it's a matrix that we can customize. So my first matrix in that product is 3 by 2, so I'm going to leave my rows as 3, and I'm going to change my number of columns to 2, and when I press OK, that will create that template for me where I can now enter the values that were in my matrix, the first matrix in the product. So entering them, I found that students want to press arrow, and that works until they get to that second entry, which was the 1 here. And if I press the right arrow now, that actually puts me to the right of the matrix. So a better option would be to use the tab key. And if I tab, that will go row by row to the next spot available in the template. I'm going to go ahead and enter all of those values that were in the first matrix. And then to the right of there, I'm going to press the multiplication symbol. And I'm going to go back to just right above there, that template button. And this time, I can choose to customize, but I actually have a 2 by 2 template available for me. I'm going to click on that and get my second matrix and fill that in. And now we have the ability to get the product using the graphing calculator, which again, on a high stakes test where students are really trying to get as many problems right, and maybe they can't remember every topic of math that they've learned, it could be helpful to enter that, as well as a little bit more efficient for students, reduce the amount of errors that they could make in multiplying the matrices. I also want to show here with matrices, so each activity I'm going to show tonight, I think Tom as well, just some sample ACT problems where you can kind of see how these activities would be helpful to students. And here are 2 problems. These are from a couple of tests in June in the last 4 years here, where it's just about that first activity that I showed tonight, which is kind of figuring out which matrices can be multiplied, and in this case, which are not possible. And so it really comes down to just kind of analyzing the dimensions of the matrices and seeing which are compatible to multiply. So here in question number 60, the one that is not possible is A times C, because if we look here at the dimensions of A and C, we notice that the number of columns in A doesn't match the number of rows in C. And over here, number 48, which of the products is undefined, really the same question. It would be X times Z for the same reason. Columns of the first doesn't match up with rows to the second. There are problems also on the ACT where students are expected to perform the different operations. And obviously, probably the toughest would be for multiplication. So it would be helpful, if students don't know how to multiply matrices, or if they forget, or if they just would feel more confident that they could use the calculator to solve that problem. And this one coming at number 57, right near the end of the test, they may be a little stressed for time, and depending on their experience, might be quicker at entering the matrix into the graphing calculator and finding the product. The next topic I want to talk about tonight are functions, both evaluating functions and evaluating some compositions of functions. There's a lot of nice features on the calculator that students can use to navigate some of the problems that they're going to see on the ACT. So I'm going to show a couple of ways to enter functions into the calculator and to work with them. One I actually like better than the other, but I'm going to show both. And for this first problem, I have a function here that's a rational function called g of x. And we're going to find g of 6 and g of negative 4, which, mathematically, again, we never want students to not know how to do the math. Students who know more math are going to definitely be more successful on the ACT, but students who know the math and can also leverage the calculator to help them are probably going to be in an even better spot. So I'm going to come to my calculator, and I'm going to enter this function actually into a graphing page. And I'm going to calculate these values by doing that. So I'm going to come to my calculator. I'm going to go ahead and start a new document. And with my new document, I'm going to open up a graphs page. And I'm going to type that function into f1 of x. And already that's why I'm not necessarily sold on this as the most appropriate method, because my function's name was g of x, and I'm entering this function into f1 of x. By the way, what I just pressed, because it's rational, a lot of times I like to press Control Divides, which is a nice way to get a fraction template on the TI-Nspire. And I'm going to press 2x minus 3 and put that over x squared plus 1. And when I press Enter, I do see the graph of that function. And since we have the graph here, I'm going to go ahead and use something called trace. And I'm going to actually trace to g of 6 and g of negative 4 on the graph. So to access trace, I'm going to go into Menu, and I'm going to go to Trace and press Graph Trace. And I've got a couple of options here. Graph Trace is actually really helpful for a number of different reasons, but especially with evaluating functions. I can keep arrowing down until I get to 6. Now, luckily, my trace step here is 3/10, I think, and since I started at 0, I can get to 6. Now, the one drawback we see here, I'm not sure how the answers would be posted on the A, B, C, and D, the answer choices, but it is a decimal, so that's not exact, and that could be a bit of a drawback. But that's one way to kind of figure out the value, numeric value of that, not necessarily as a improper fraction, which might be the way that the answers are posted. Now, negative 4, instead of tracing back, I don't think I'd actually hit negative 4 if I arrowed back. You can actually type in the value you want to kind of snap to, and I'm going to press negative. And notice right here that a box opened up saying x equals, and if I type in 4 and I press Enter, it will actually snap to the value at x equals negative 4. And so I found that to be really helpful, not just for ACT purposes, just for analyzing functions a little bit. There's another way that might be a little bit better with the function being entered into f1 of x, and that would be if I insert a calculator page. So I'm going to go to Doc, and I'm going to go down to Insert, and I'm going to insert a calculator page. And now I have the ability to refer back to that function called f1 of x. Now, if you're ever confused about what you had entered in the calculator, you can press var, and that can kind of lead you back to what you have available to you. And we've entered something to f1, and that's why when I press var, we see that f1 of x has something in it. So I'm going to go ahead and click on that. You can also type f1. In fact, I'm just going to go back a second and do that. But notice again that when I typed f1, kind of like with the matrices before, it showed up bold. And it does that because there's something stored in f1, and it's ready to use if I put something here in the parentheses. And the something that I'm going to put is that 6 that they asked me to evaluate the function at. And there I get the exact value of the function at x equals 6, which is kind of nice because that might be one of the answer choices. And then f1 of negative 4. So one way that we can use the calculator to evaluate functions is by entering that function here into f1 of x and either tracing or evaluating on a calculator screen. And that's nice and helpful maybe if we have one function, but click through the slides related to that. What if we have two functions and we're evaluating a composition of functions? then it might be a little bit more challenging to call them f1 of x and f2 of x, and which is g of x and which is h of x. So, I'm going to show the math here real quick. And again, it can be a little tedious. Now, I don't think these are too, overly difficult functions. We've got a linear and a quadratic. We've got some nice numbers going in. But, students could have some trouble with the computation if they're not careful, or they may not even understand the idea of a composition, depending on where they're at. But we're going to go ahead and define those two functions on a calculator screen and use them as g of x and h of x. I'm going to come back to my calculator. I'm going to start a new document again, just so I don't have anything stored anywhere. And I'm going to open up a calculator page here. And I'm actually going to define g of x. And I'm going to define it this time by pressing menu. And in menu, the first option is actions. And that's where I can find the define command. And I'm going to select define there. And it's going to type define, and now it's just waiting for me to define the function. I'm going to type it in as g of x equals 4x minus 3. And if I press enter, it says done because now it's entered there. And again, I'm going to go ahead and I'm going to define. I'm going to go up, and this time I'm going to highlight define. That way I don't have to access the define command. And I'm going to just back this up a little bit. And I'm going to change this, sorry, screen froze for just a second. I'm going to define this as h of x equals, and again, it's a fraction there, so I'm going to go x squared over 2 plus 1. And now g of x and h of x are in the calculator. And so I think if we look back here, the two things we want to define were g of h of 4 and h of g of 4. And so now it's just as simple as typing that on the screen. So g of h of 4, and notice both of those are bold, and h of g of 4. And we can get those values really quick that way. And depending on how complicated that the functions are, that might be a way to leverage the calculator for a little bit of success on that type of problem. One thing that I recently learned, which is kind of neat, is we could actually define on the Nspire functions that involve more than one variable. So here's a function called g that involves two variables named a and b. And the idea here is that, mathematically, we'd fill in the first part of the coordinate for a and the second for b. And but we can also use the calculator to do that. We're going to see an example of a test question here in just a bit where this might be really helpful. So I'm going to come back to my calculator screen, and I'm going to again hit menu and actions and define. And here I'm just going to type, now the g here, notice it's bold, but I'm actually going to override that because when I enter in g of a comma b equals the a squared plus 3b, that's going to override what I've had in g, even though I didn't open up a new calculator page. And I think I was trying to find g of 4 comma negative 2, and just like with the functions above, I can tell it g of 4 comma negative 2, it will evaluate that function with more than two variables, filling in the 4 and the negative 2. So that's kind of the handy thing to have. And we're going to actually see a problem here in just a little bit that does that. So there are some nice things that the calculator can do with functions. One thing the calculator can't do, at least the TI-Nspire CX that you can have on the ACT, is to evaluate functions with variable expressions. Students are pretty successful in my classes anyway with functions of filling in values and finding outputs from a given input. But when it's a variable expression, that's always a little bit more challenging, especially here when we have a quadratic to fill into. My students, I just graded a set of quizzes this week where we didn't end up with 3 terms when we squared that binomial. It was just x squared plus 16. Got some work to do. But one thing we need to realize is that if we do this on the TI-Nspire CX, and here's a screenshot, I'm going to go ahead and show you this, we're going to be told an error message. The variable's not defined. It's not able to work with that variable. Now, if you have the CAS version of the calculator, that's pretty nice because it can work with that. But we need to realize that the CAS is not something that's actually allowed on the ACT. So students are going to have to, and I just noticed I don't have the correct expression entered in here. It's supposed to match up to x minus 4. But students are going to have to know a little bit more about how to do this or find a different strategy in order to solve a problem like this if they struggle to find something like g of x minus 4. So a few questions to look at where sample ACT problems where these skills could be and strategies could be used. Here's just one very similar to the example I showed with two different functions, f of x and g of x. Here's the math part of how to do it and then how to use the calculator to verify that and find the final output of f of g of 4. Here's one, and this is the one I was kind of foreshadowing here a little bit. This is a function defined with 3 variables. And if we take a look, one of the variables is actually squared. We've got a difference in here. One of the values is negative. There's a lot of places that students could make a mistake on this type of problem by filling in and even evaluating, even with a calculator evaluating with it. But if they type in and define a function with 3 variables and then evaluate it, that might be a little bit more effective way to answer that type of question. And then I really like this last one I'm going to show because even though it's just a function in 1 variable, we've got a lot of negative 4s going on here. We've got a negative 4 is the lead coefficient here on x cubed. We've got a negative 4 is the quadratic coefficient here. We've got a negative 4 we're filling in, and just a lot of places for students to make a lot of mistakes here. But if they just define that function, f of x, and type it in as it's written, and evaluate f of negative 4, they might have a little more success in coming out with 192. So that's some ideas on functions, and I think I have just a little bit more time, so I'm going to just show a couple of things about systems of equations, one of which I think is kind of a game changer with the Nspire CX. So here's a system of equations, and just to review some of the algebraic methods, there's actually quite a lot of problems on the ACT that involve systems of linear equations. So it's definitely to the student's advantage to have multiple strategies. We'd love for them to have some algebraic strategies that are quick and efficient and making good choices in the methods they choose. So here, maybe using the substitution method would be a good choice, or elimination because they're both written in standard form. That kind of represents a good choice to solving this. But how can we leverage some success using the calculator? So this system, both equations are written in standard form, which, as we know, typically on a graphing calculator doesn't go well because we normally have to enter something into y equals. So I'm going to pull up a graphs page here and show something that maybe you do or don't know about the Nspire. Right now I'm in function mode, so I need my linear functions here to be written in y equals form. However, if I just hit delete and backspace over that equal sign, I get a few options to enter some non-functions perhaps, or in this case it will still be a function, but that's where we can find our inequalities, as well as this one that I use quite a bit, a relation. And now if I click on that, the screen changes a little bit and I'm able to enter my equations as relations. So I can actually type in x plus 2y equals 2, and I see the graph of that line, and I can enter, and again, if I go back, now notice normally when we go back, either by hitting tab or I hit Control G just there, it would show F2. Here it shows relation to, and I'm going to enter negative 3x minus y equals 9. And because I can see the intersection on the screen, I'm going to go in and just like an intersection of two lines at any time, I'm going to hit Menu, Analyze Graph, and select Intersection. It will give me that vertical line here. It wants to know a lower bound and an upper bound. So I'm going to select something a little bit to the left of that intersection point and something a little bit to the right of that. And I find the solution just that we saw before algebraically is negative 4, 3. And then just one more way, and this kind of ties back, actually 2 more ways. This way I want to show because I think some people aren't aware that this is a tool that you have on the calculator, and that's to actually use the solve a system of linear equations in the algebra menu. So I'm going to click here, I'm going to insert, another way to insert a page in your graphing calculator, Control I usually tell my students that, it's just a quicker way, Control I, and I'm going to insert a calculator page. And if I go into menu and I scroll down here to algebra, we actually have the ability to solve a system of linear equations. And this is on the non-CAS version of the calculator. And you can solve a system with more than 2 variables, but typically we probably do 2 or 3. So you have an ability to kind of change this based on your needs. But it pops up a template here, and if I enter my 2 equations, I end up getting the same solution I had before. And it's very easy to enter those in. It set up a template. It's solving that system for x comma y. And if I press enter, it gives me that solution. Now here it's listed as a solution set, but it tells you that it's in the form x comma y. And so that's kind of nice, and that can be really helpful, especially if you're doing a lot of problems involving systems and you've learned how to solve systems algebraically in a number of ways, but you want to get to the solution a little bit quicker. Okay. The last way we can solve this, and I'm not going to spend much time on the calculator, but just to kind of tie back to matrices, because I know Tom's ready to get going on that 84 there. You could actually make what we call an augmented matrix, and that would be formed by using the coefficients of the x terms and the y terms and then the constants, and using something called RREF, which can be found in the, I'll just show you real quick, it can be found in the menu and matrix and vector, reduced row echelon form. Those of you who studied some linear algebra would know that one. And by doing reduced row echelon form of that matrix, you can get a matrix that's simplified here that tells you here that the x-coordinate, that's what that 1 in the first column represents, is -4, and that the y-coordinate is 3. So yet another way. There's many ways that we can solve systems on the Nspire. So just a couple of sample ACT problems. I pulled this one because it just shows that even if you don't use row reduced echelon form, they do ask questions from time to time about forming an augmented matrix to represent the system below, which most students might just kind of guess that it's that one, but that was a question in one of the AP tests. And then a couple of system questions, and we've been noticing that at times they don't often give us the solutions to the system in the form of x comma y, but ask questions like, what is the sum? Reason being that if they just have the solutions, students could just plug them in. So if they need to know the sum, you kind of actually need to know both parts or be able to kind of find a way to find the sum of x and y algebraically with your equations. So they kind of added an extra little wrinkle at times. But any of the tools that we talked about and any of the methods would still help you answer the questions. And here's another one where your goal is just to solve for B versus A. So algebraically, you would probably do something to eliminate A and just solve for B, or use a calculator tool and then just pick what B is. So I think that's enough for the Nspire tonight. Tom, are you ready to go with the 84?
Yep, ready to go.
Okay, I'm going to go ahead and assign this to you. And I'm excited to learn some things about the 84.
Did I get the screen or did you give it to Mike?
I think you've got it. You've got to share yours.
Tom, you good?
I'm just seeing your screen, Mike.
The PowerPoint?
Yeah.
So you should be able to go to the very top of that WebEx menu and choose Share.
Yeah. Okay. It was locked
There you
on. Okay, there we go. Okay, so so here we are on using the ACT prep. First of all, Scott, very nice job. And it's saying I can annotate. I do not want to annotate.
I got that message quite a few times as well.
Yeah. All right, so now I'm not annotating. So Scott, we'll start off by giving you a Pez for your.
Oh, great. Thank you. That's my first test from you.
There. Okay.
Appreciate it.
Also, before we get started, Mike, are there any questions that popped up for Mike before we go on? Or for Scott, rather, before we go on?
I didn't see any questions for Mike or for Scott, so we're good.
Okay. All right. Sorry about that. Okay. So this is the webinar, and this is a website that has all the materials. Mike will share with you also another website with materials, but it is case sensitive if you're interested in getting those materials. And they'll pop up every so often on some of my slides. Two things I do want to point out about the ACT. You can use a graphing calculator, whether it be an Nspire or an 84 or 84 CE, just it has to be non-CAS. And 60 questions in 60 minutes. So that would be a question per minute, right? And actually that's not right. The problems do get more difficult as you go along. So we suggest the 30, 60, 90 approach. The first 20 questions you should try to do in 30 seconds if possible. 21 through 40 done in 60 seconds and needing about 90 seconds for the last 20. So if you're doing it a minute per problem on the first 20, you're never going to probably get finished. So be aware of that, and that's on an average. All right, so I do want to look at, I don't want the Nspire to show up the 84 too much here, so I thought I would show how you can solve a system. Keep in mind, if they said solve this system, you could use your calculator and press some buttons and get it. I'm not sure I agree with that in my classroom, but if it's allowed on the ACT and it's a high stakes test, please allow your students to do this. So let's go ahead and look at that, similar to what what Scott showed. So under apps, if you press the apps button, the 9th one on my calculator is the Poly Simultaneous Equation Solver number 2. And when you run that application, you have several things on the main menu. The second one is the one I want to look at, and that is Simultaneous Equation Solver. So I'll press 2 or enter here. And notice you can do up to a 10 by 10, which is kind of amazing. For those who've not done an app before, you'll notice these keywords down along the bottom. Those correspond to the 5 hotkeys along the top. So y equals goes to the main, graph goes to next, and so on. So I'm going to press the graph key to go to the next screen. And it's ready for me to type in my equation. And so my equation was 9x. I'll type in a 9 and enter. And notice I can even change the plus to a minus there instead of having a plus a negative. 7y, and then is equal to -4. Make sure it's a negative sign and not a minus. Notice it jumps to the beginning of the next one. 5, enter. I can just press enter because I like the plus sign. 8y, and then equals 1. So my equation, 9x minus 7y equals -4, and the other one, 5x plus 8y equals 1. To solve it, notice the graph key is what I'll press to solve it, and these are the solutions. And I'm thinking most of you are thinking that's probably the solution you thought of when you first saw this, the system. But I'd like to show my students that these check. Again, on the ACT, you do not need to do that, but I think it's a good teaching practice is have them see that. So I'm going to go off to the home screen. So one thing, I'm going to press main to go back to the main menu. And then anytime you use an app, it's very important that you quit it. So I'm going to quit the app, number 6. So my solutions were negative and then fraction 25 over 107. Now get out of the fraction and press the stow key and store that in for x. And then I'll need the fraction 29 over 107. Get out of the fraction, store that into alpha 1, which is the letter y. And I want to make sure it checks in both equations. So I'll type in the left-hand side of the first one, 9x minus 7 alpha y. And before I press enter, I want to make sure my students understand what's going on. Taking the current values of x and y, substituting them, multiplying them, subtracting them, and -4 is what I was hoping to get, but it has to satisfy both equations. So 5x plus 8 alpha y, and then substituting gets me 1, and that does actually check. So we solved the system using the Poly Simultaneous 2 app. And this is what it would look like. Okay, these are the things I went through to get it, so you can see that. And I showed the check. Okay, very important for them to see that. So thank you, Scott, for kind of giving me a good lead in for that one.
Sure.
All right, so I want to point out these activities are not a quick fix. That's not the idea. To quote my geometry and algebra 2 teacher from many, many years ago, Mr. Erickson, kids would ask him, why do we have to learn this stuff? And his reply would be, I'm not trying to get you into college. I'm trying to get you out, meaning there's no quick fix. I want you to get through college. I want you to be successful in your career. So it's not just, let's just do well on the ACT. And definitely what we're proposing here too, not just that part. All right, so the first one I look at is Pythagorean theorem and triples activity. These are two recent examples from the ACT from December 2017 and June of 2017, and we'll come back and do those shortly. But I do want to also point out the creators of the ACT test the topics that we teach, but they ask questions very differently from how and what we ask, and definitely how textbooks ask. And my opinion is this needs to change. And you do that by bringing in at least one ACT problem per day so that they get familiar with different ways of asking questions. And a fact that I learned over 30 years ago is if your students know and can recognize Pythagorean triples and their multiples, they will do much better on the ACT and in future math classes. So to help us prepare for that, we have some activities. We also have a program that we developed that works on both the 84 grayscale and the 84 color. And I do want to illustrate that for you so that if you're interested in it, you can download it tonight and use it in your class tomorrow. So I'm going to go ahead and press the program, and the name of the program is Pyth-Trip. Sounds awful, but it can only have up to 8 characters. So I'm going to run or execute Pyth-Trip. And again, this works on the 84 or 84 color. If you'll notice in the upper right-hand corner, it has a agitated white circle. That means you're in pause mode. So to get out of pause mode, it tells you to press enter to continue. And it shows you the menu there, okay? So the first one is triple or not, so I'm going to press 1 or enter. And it says, given 3 numbers, decide if they form a Pythagorean triple or not, press enter to continue. So if it is a triple, you press 1. If it's not, you press 0. And if you want to go back to the main menu, you press 9. So 3, 4, 5, I'm saying it is, so I'm going to press 1, and it tells me I'm correct. And then I'll press enter to continue. 4, 5, 6, I'm going to make a mistake here. I'm going to say it is a triple, and it's going to tell me incorrect. It's not. 8, 15, 17, I think that is. Yeah, it is. And then you get the idea. So I'm going to go now back to the main menu by pressing 9. 2 is finish the triple. So if you do the finish the triple, 6, 8, what? You actually have to type in the number you think will finish the triple, and if it tells you if you're right or not. 5, 12, 14, 13, so close. I'll learn these someday. 8, 15, 17, I think, okay. And notice when I'm tired of doing this, I'll just press 99. And then the third one is missing number in a triple, and 5 something, 13, and it's very similar. So just kind of go through and do that. There's several of them. I'm really just kind of showing you what's going on there. And then even when you quit, notice I'm still trying to get you to learn them. Here's a list of some of the most popular Pythagorean triples. I'm still trying to teach there at the end. So this is available color and grayscale. Hopefully you can use it. All right, so let's go back to the ACT questions and look at solving them. So this is number 32, which means this will be 60 seconds allowed on this problem. It says, which of the following values is closest to the distance in feet between radar stations A and B? So one of the things I would hope my students realize is they see a set of triples. 9, 12, 15,000 is really a multiple of 3, 4, 5. Not that you need to know that, but I just make sure you realize you have a right triangle. And then there's a second set of triples because you've got a right angle on the other side of angle D there. Something 12,000, 13,000. And this, of course, is a 5, 12, 13, only it's a multiple of it. So 5,000 it pops up. And you'll notice that 5,000 is one of the distractors. And ACT people are like that, where they'll include halfway answers. And we tell one of our strategies is don't fall for the halfway answer. Always reread the question, not the whole problem, just the question, making sure you're answering the right one. In this case, 9,000 plus 5,000 is 14,000, which is letter J. If you didn't know Pythagorean triples, you could do this, but you'd have an equation like x squared plus 12,000 squared equals 13,000 squared. Even with a calculator, you got a lot of zeros, a lot of chance for error. Here, this is a real quick problem if you know the Pythagorean triples. Second example is one of my favorites, number 44, a 90-seconder. But to me, if you know what you're doing, you can get this done in less than 20 seconds. So the solution is one of the things we suggest in geometry is to draw in auxiliary lines. If you draw in segment BD, Pythagorean triple should fly off the page at you, 3, 4, 5. And then also another Pythagorean triple is there, 5, 12, 13, which makes it a right angle at BDA. And once you have that, you can now talk about the tangent of angle A, opposite over adjacent, 5, 12. So again, this is done real quickly if you know the triples. If you don't, you could be there forever. I have had some students tell me they weren't sure, they didn't draw on the auxiliary line, they didn't know what to do, but they eliminated G and J because they had 5s in them and there were no 5s in the original problem. And of course, they eliminated one of the correct answers. Careful. A second thing I want to look at is absolute value. And you might say, really? Do you really need to do this? I mean, absolute value is always either positive or 0. And the way they ask questions is the answer is automatically yes. Okay, so we go back to the definition, only a little bit more advanced. So absolute value of A minus B is either equal to itself or it's equal to its opposite. But I don't want to stop there because I would like to rewrite that as the opposite of A plus B, or even as a subtraction problem. And ACT loves that you know and recognize equivalent forms. And so your students need to know all 3 of those forms on the right, not just one of them, because you never know which one they're going to use. So to help the students do that, one of our student activities is equivalent forms, rewrite A minus, the absolute value of A minus B equals 7, and then take that second equation and rewrite it in 2 other forms. Just practice that. Okay, just practice that. And the reason for it is when you get to a problem like number 45, which again is another 90-second problem, it says which of the following expressions is equal to the absolute value of A minus B minus C. If you're not trained, just like I showed you, the students will just say, I always thought it was just a positive number. What's going on here? So they either guess, or they might put numbers in for A, B, and C and see which one of these are equal. But if they are using the ideas in the student activity and realize opposites, absolute values of opposites are equal, then D hopefully would jump off the page right there, okay? Graphically, I think it's important that students understand what the absolute value of a graph looks like. So here's the graph of f of x in blue. Here's the graph of that same function in red. And then kind of toggle back and forth. Here it is in blue and red, blue for the function, red for the absolute value, blue for the function, red for the absolute value. You kind of see the patterns there. In fact, I think there's a real simple graphing discovery activity that I'm going to share with you right now that I would love if you tried it, okay? So I'm going to go back to the 84, and this, by the way, this would work on Nspire just as well. And I'm going to go to y equals, and in y equals, I'll type in any function, in this case, something simple like even y equals x. But in y2, which is red, if you look at this, I made it so that the line is the thinner line so that you can see both the red and the blue at the same time. And in y2, I'm going to have y2 be the absolute value of whatever's in y1. And the absolute value can be found at alpha window, where a bunch of the other templates are found. And I'll just go alpha trace to get the y1 variable. And so when I graph this, you'll notice a graph of y equals x is in blue. That's pretty standard. And here where it's red and blue, they're the same. But right here, you'll notice when blue goes down in the 3rd quadrant, red pops up and its absolute value pops up into the 2nd quadrant. It's a reflection over the x-axis. So they can start doing different functions. Like, for example, I could even try y equals x squared and then graph it. And you'll notice that they're identical. The absolute value of x squared, it has the same graph as as x squared does. If I go back to y equals x squared, if I did y equals x squared minus 4, it's going to be there in blue and in red. You can see it's the same in the 1st and 2nd quadrants, but it's reflected up or flipped up here in the 1st and 2nd quadrants. You can even go down here and maybe even go with something like 5 minus x squared. And again, you've got, here's the reflections of each other. Here they are exactly the same because they're in the first and second quadrant. So again, just a real quick activity to help students visualize this. And when we field tested this with students, they would say, I really don't see why you're doing this. Our teachers never made us learn it this way. And here is the reason why. Problem like June 6, 2016, number 54, a 90-second problem. Says the graphs of F and G are shown below. Which of the following is not true? And if you're not trained to understand absolute values of graphs, or notice even this, composition from a graph, whether functions are equal at two different, I mean, this is just kind of a mess. But if you're doing this one, so if you're doing this one, you can see that the absolute value of that parabola is the parabola itself, but the absolute value of that line is not, because right over here it would pop up and make that V. And so I don't even have to worry about H, J, and K. So again, a 90-second problem with the proper training turns into a 20-second problem. Any questions popping up, Mike? Are we anything I need to go with?
So far, so good, Tom.
Okay. Percents, again, some people say, oh, you got to be kidding me. You really got to talk about this. Yeah, you do. One of the things that I really hope that students understand are the common equivalents, so much so that I used to have them make flashcards. So since we did that, I also have electronic flashcards on the 84. By the way, all these are available on Nspire as well. The files are at that bit.ly website that I showed you. So I'm going to run a program. This one is called Percents or Percent. It just has you make sure you know the equivalents, okay? For example, decimal to percent. Given a decimal, write it as a percent. So 0.1, type in 10%, tells you if you're correct. Here I'll type in 0.4%, again, correct. 2 is 20%. Oops, no, it's 200. I got to learn that one, okay? And then I'll go to 99 for the main menu. And then the last one, mixed, they're all mixed up. Now you have to go from decimal to percent, percent to fraction. And even notice here on fraction, as long as it's an equivalent fraction, it'll tell you you're correct. So anyway, if you're interested in that, there it is. You got that. But going back to how does this help on the ACT? Well, so one of the things that pops up a lot is this discount and coat that normally sells for $165 on sale for 20% off. What is the sale price? The common solution is this one. You talk to almost anybody in America, they'll hopefully if they do it correctly, they'll multiply by 0.2. That's the discount, subtract from 165, everybody's happy. The second way, we would strongly urge you to do it for many reasons. If you have a discount of 20%, you're paying 80%, so multiply by 80% or 0.8, and notice it's less steps, less chance for error, quicker, and so on. And then it's a good idea to understand both solutions, but really kind of push the second one, especially when you're talking about exponential growth and decay, and use a calculator. Okay, so they use your calculator correctly. Remember, you're allowed to use it on this high stakes test on every question. Then percent increase is even more important to me. Let's say the store needs to increase all their prices by 8%. Something used to sell for $125. What's going to be its updated price? All right, what I call the old way, multiply by 8%, add it on. Second way is, since you're adding 8%, now you're paying for 108%, which is 1.8 times it. Again, excuse me, I think quicker, less chance for error. And when you're talking about exponential growth, this is the way to go. Something increasing by 8% every year, that would be the way you write it, 1.08. Sample questions from the ACT. This one is a 30-second problem. Dimitri brought a pair of pants at the discounted price of $30. Original price is $40. What's the percent of the discount? Notice that the distractors look very good. Again, these people who write them, they're kind of creepy. They're out to get us. A common answer would be B, 10, because it lost $10, but it's $10, not 10%. 3/4, oh yeah, 75%. The teacher made me memorize that. That's how much you're paying, not the discount. So there's several ways to do this. This was just one way that I came up with, but there are several ways you could do this problem correctly. Also a whole bunch that you could do incorrectly. This one is more of a 90-second problem. And so this one says the plans for a diving pool call for a rectangular prism, length 30, width 25, depth 5. The plans would change to increase both the length and the width by 10%. What will be the increase to the nearest percent in the volume of the pool? It's the long way, but I think the traditional way would say, well, find the original volume, take 10% of each of them and add it on, and then get a new volume. And then if you divide them, you can see you have 100% plus 20%, 21% increase. If the students are a little bit more algebraic, you might want to do it this way. The original volume is length times width times height. The new volume is going to be 1.1 times the length, 1.1 times the width. And when you multiply the constants and then factor it out, it's 1.21 times the original, which again is a 21% increase. Get your students to think that way. They have a better chance to use less time because they need to create that time. All right, so where are we here? We've got a minute, so I'm not going to be able to do much in a minute. So let me skip ahead here. Instead of showing the calculator part here on how to calculate mean, median, mode, and range, I think I'll just show this one real quickly and turn this back over to Mike. This is a standard test question on the ACT. Got 4 tests. What do I got to do to get at least an 80 on the last test? You could do this algebraically. A lot of students will say you want an average of an 80 or 5 tests. Some needs to be 400. Subtract what you already have, and you got to get a 91. Okay. Just want to throw out one other way that we've created over the several years, and that is after the first test, Pete is 70 or 10 below where he should be at 80. After the second test, he lost another 6 points, so he's now down 16. But on the third test, he gains 2 points, so now he's only down 14. On the fourth test, he gains 3 more, he's down 11. So if he needs at least an 80 and he's down 11, he's got to have a 91. We call this the golf score method. And so I highly recommend this. This is a great way for students to understand this concept about average. So with that, let me just kind of skip ahead here and wish everybody a nice Pez. I can get through this. There we go, nice Pez. And turn it back over to Mike. Thank you, Mike.
Thanks, Tom. Thanks, Scott, for everything you guys shared.
And assign this back to you.
Got it.
Good.
Thanks. If you do have any last-minute questions for Scott or Tom, please try to get those asked. I know they'll do their best to get those questions answered. One thing we have a promotion right now on our website is an extra credit promotion. Sorry, losing my words. And whenever you participate in our extra credit promotion, you earn entries into drawings, and with those drawings you can win different prizes. So doing things that you probably already do, like attending this webinar, you can gain, again, entries. And so you'll need a code for tonight to prove that you're at this webinar. And the code for tonight is not case sensitive. It is ACE, the ACT. I'm going to put that in the chat window, ACE, the ACT. Again, if you want to learn more about the extra credit contest, feel free to visit our website to learn a little more. We're excited that the T-Cubed International Conference is coming to Dallas this coming March. It's a great way to connect with fellow educators. And as Scott mentioned at the very beginning of the webinar, one lucky winner tonight is winning a free conference registration to that T-Cubed International Conference. And tonight's lucky winner is Sarah Butler. So Sarah, congratulations. We'll be in touch over email in the next couple of days to give you a little more information. But we hope to see Sarah as well as everyone else at the T-Cubed International Conference. To receive a certificate of attendance, go ahead and click the link in the chat window. Also listed as a link for the documents that were used tonight by Scott and Tom. And if you miss these links for any reason, have no fear, you'll automatically get a follow-up email within a couple days. And in that follow-up email will be links to the recording, the certificate, and the documents. And if you're watching this on demand, go and copy that link into your favorite browser to receive your certificate. Thanks so much, Scott and Tom, for everything shared tonight. It definitely gives me a lot to think about as I help my students prepare for the ACT.
Thank you.
Have a good night, everybody.
Thanks for joining us. We hope to see you back online real soon. Have a great night.